Greetings, let's say we want to multiply the matrices we see right here, and we want to use the method that involves focusing on the columns. So for that, I would mark this matrix as A, this one as B. So what we're doing is A times B. So we're multiplying B by A from the left side. And this is an example. In general, we can generalize it more, but in this one, we're focusing on solving this example. So basically, when you do that, is on the right side is the column whose vectors you want to see, the column vectors. You want to, on the right side is the matrix where you want to locate the column vectors. And those you will just multiply each of them by A. And that means that the result of it, we will have, by the way, this matrix is 2 by 2, meaning 2 rows and 2 columns. The B is also right below here. I'm just talking about the dimensions, amount of entries. B is also 2 by 2. In this case, it's a good case that's simple. It's a very basic case where both have the same dimension. The final dimension when there is matrix multiplication is the rows of the final matrix are the amount of rows of the left matrix, and the amount of columns of the right matrix is the amount of columns of the final matrix. So our result will be a matrix like this. Now I'm drawing it a little bit bigger than the previous two, but still it's going to be the same amount of entries by theory. And it's going to be 2 by 2, the ones I underlined in the order that they were underlined. And so we have A and B, and A was circled because when A multiplies B from the left, the result we get for the final matrix, if we're following the column way of doing the multiplication, and there's more ways. There's also, for example, entry by entry way. And there's also a way that focuses on the rows. But in this one, we're doing this one. It works the way that we take each column from B, as was shown, circled right here in the beginning of talking about it, and then we multiply it by the whole A. So I will first write the scheme before we actually do it. So A will multiply, in this case, the 2, 1. That will generate the first column of the result. So the result, again, 2 entry columns. And also it multiplies, A also multiplies the other vector which is 3, 2. All right, so we get that. And now what does it mean when A multiplies 2 and 1? By the way, let's say we're talking of real numbers. There's commutativity, so the order of multiplication doesn't matter. And actually, it won't matter now when we're multiplying a matrix by a vector, because we're doing it we have one column in that vector. It's a matrix of one column and n rows, in this case 2 rows. And so if we multiply the matrix from the left or from the right by this vector, the thing is the result is same, but that doesn't necessarily happen with matrices. So if we multiply by a bigger matrix, not just a column vector, but by a bigger matrix. But now we're dealing with the situation that we're dealing with. So if you want to continue now, basically multiplying by A from the left side, the 2, 1, or by A from the left side, the 3, 2, means taking a linear combination of A according to the vector 2, 1 or 3, 2 respectively. And that means, this is a thing that one should probably know in advance before going to how to multiply matrices, because there's sort of technicality involving this in a way, and it's more smooth when one knew that before. So basically the way this is done is, let me talk about, for example, this one first. The end result we want is really a 2 by 2 matrix, all right? We've already stated the result was going to be 2 by 2, so that's still clear, didn't change at all. But what we want to see the exact entries. Well, let's now calculate this part and this part separately over on below what we've written so far, just for the sake of clarity. Well, A multiplies, I can just write like this: 2, 3, 1, 2, multiplying that 2, 1. And as we saw, we can show that it's the same if we multiply by the 2 by 1 vector from the left or right to this matrix, but we can still write it like this. We're taking a linear multiplication of the actual columns of A. So it might seem like A is distributed over B, but then when we actually look at the concrete column vector from B that we multiply by A, actually that column vector from B, each of them takes a linear combination of A's columns. And so we'll take the 2 first and multiply the first column of A, 2, 3, and then to that add, and the second entry of the vector, 1 times the second column. And now we follow addition of vectors and so on. So these are definitely things to know before going to such topics like matrix multiplication, because it's really necessary to know these technicalities to be smooth in this. So we have 4, 6 as a vector, and this is all going to be in one vector in the end, according to all the rules that definitely I recommend you to know first. All right, so we get this, and this is not a matrix, it's really a plus sign, so we just reduce it in complexity of, so it's 5 and 8. So that's the first column. All right, and the same will go for the second column. Now we don't have to write it out, but we could perhaps, I mean, we could do that, but what we can just do, and when you're actually doing it in reality, perhaps a quicker way and more common way when one go faster at it, take the 3, 2, and imagine you are multiplying the first column 2, 3 by 3 and add to it the second column 1, 2 times because of the 2. And so what we get is, for the first row, sort of, now a result is going to be a column that will just get absorbed here, right? The parentheses of that column will disappear and we will just leave the entries there, even though we've been seeing the matrix be broken up into those column vectors, but we'll now look at it that original way again, just the entries. So 3, 2, and take a linear combination of A by that. So 3 times 2 and 2 times 1 will be in the first entry of the vector, and in the second entry will be 3 times 3 and 2 times 2. Well, that will get 13 right here, and it will give 8 right here. And now what we basically did when we did in our head, we sort of thought in that entry by entry matrix multiplication method. All right, so we didn't really follow that previous method. And again, that points back at the point that it depends on the case. When is which method more practical? So in this case, perhaps one could do that entry by entry method. Let's say that one for another one, perhaps. If we want to compare, for example, another one like entries and method and column method. And there's also something called row method that we might do in another one.